And we are back. So, first presentation, now the last one. So let's talk about interesting technical stuff now. So one of our latest developments in RouterOS version 6 is called FastPass, and I will give you the all information that you need to know about that. So where did this original idea from FastPass came from? It was that many clients that had a question why this Realtek router with doing simple NAT and some stuff can do a wire speed, and why when you have a MikroTik router you get a little bit slower performance, so not wire speed. So where is the problem? Of course the problem was that some of the hardware have these hardware chips and they implement features in the hardware, so you can have up to 20 firewall rules but not more, because chip doesn't support more. You can have a NAT rule and that's basically it. You cannot have a custom configuration and so on. As you know, RouterOS have more than a few features. In fact, to explain some of the customers what happens when in RouterOS, we had to make a packet flow diagram to explain it. So it consists of, and of course it stops in exactly the right moment when I need it. So this is the RouterOS version 6 packet flow diagram. That basic diagram, if you go deeper, okay, I have to turn it on. Yes. If we go deeper into this, and this section, these look like these. So as you can see, there's lots of interesting boxes, bridge destination NAT, use IP firewall, and so on. So all those are configuration facilities in RouterOS, and it shows exactly in what order it happens in RouterOS. So for example, when will you see the address of the packet that's originally came to the router, and when you will see the new address that already not changed, and so on. So you really need that diagram. And of course, we have to go even deeper when we go talking about firewall stuff and such things. So basically, the whole RouterOS diagram is 3 pages and lots of explanation. So that's why, because packet have to travel through all these facilities, we get a little bit slower performance than wire speed routers that have hardware features. And that's why we call, right now we'll call all the regular way how packet process through the router, we call it slow pass. So slow pass is a regular way. So basically RouterOS packet need to check through all the facilities, and it's a considerable number of steps. Just to illustrate, for example, simple bridge forwarding is going through the diagram like this. And in fact, if you look deeper, there's 7 steps in what order simple bridge forwarding have to proceed through the RouterOS. If we go for MPLS forwarding, so it's the next big box. MPLS is much more simpler and faster, so only 2 boxes in case of forwarding you need to cross. And if we're talking about the most complex stuff in RouterOS, it's routing forwarding. So you go through the last box over here. In here it looks quite simple, but you need to remember that each of those boxes stand for many other options over here. So basically, this is explanation why some of our equipment cannot reach wire speeds when you use some specific features and such things. So that's why we try to create a feature, a FastPass. So if you don't use most of those features, how can you get most out of the router, MikroTik router that you had? So we made a first implementation of FastPass. So initial implementation of FastPass. So what FastPass is? FastPass is an interface driver extension. So basically it's addition to the driver of the Ethernet or wireless or tunnels. So basically it allows to receive, process, and send traffic without any unnecessary processing. So basically router-S driver can talk directly to the specific facility that you need and skip everything else. So what you need to run FastPass, you need to interface driver support, you need to have FastPass enabled in configuration, and you should not supposed to have some configuration in some specific facilities. So we'll talk each step through. So driver support, as you can see from the list over here, all the newest hardware have driver support that supports FastPass. So I can show you some only exceptions. So on 1100s, as you can see, 2 ports are missing. 12 and 13 are not here. And also on 800 and 600, Ethernet port 3 is not here. Those ports are PCI Express ports, so they are not directly connected to the CPU. So FastPass is not possible on those. So that's why they are excluded from that. Also, on the wireless, you just need to have a proper package. So it's wireless CM2 or REP, or discontinued wireless FP, which actually stands for FastPass. But all 3 packages like these have FastPass support. If you still use old wireless package in some old version, it doesn't have a FastPass support. Next thing, you need to make sure that FastPass is enabled in the configuration. So it's enabled by default, but you can always uncheck this value here for IP forwarding, or over here for bridge forwarding. It's a bridge settings and IP settings. And you can also check how much traffic travels through your device in a FastPass mode. So, of course, that meant that we need to change something in our configuration. Before, connection tracking was either on or off. So enabled yes, enabled no. Now we added auto mode. That means that if you don't have any rules in your firewall, it will be off automatically. As soon as you add at least one rule, it will enable itself also. So this initial FastPass works like this. So we basically check all the facilities if there are any configuration. If there are no configuration, bridging decision talks directly to the FastPass in the driver. So driver already knows exactly where to send that traffic out. So instead of going through the whole diagram, it just sends it to the out interface. That's it. That's how FastPass works. So only by communicating with bridging decision. If we're talking about routing, it's a principle exactly the same. So if there's no configuration in these facilities, again, routing decision directly talks to the FastPass in the driver, and traffic is sent directly to the next thing. Of course, when we're talking about routing, there's much more facilities that you need to check to see that are there any configuration. And with these changes, we actually were able to get the true potential of hardware out. So if any one of you have seen routerboard.com page and go into any of our hardware, we have this table of performance for each product, and you can see what happens if you put device into simple bridge mode. So simple bridge mode, no other configurations except the bridge, so that means that it is FastPass. So as you can see, you can get 770,000 packets per second. As soon as you add 25 bridge firewall rules, you will go out of the FastPass, you will go the normal regular slow pass way, and you see that traffic performance drops drastically 7 times in this case. So if we take a look at the Cloud Core Router 72 core, you can actually get wire speed when you're bridging in the Fastpass. So basically, I don't know why, but if you use 72 core as a switch, so just bridge all the ports together, you can actually work on wire speed without any issues. So that's 119 million packets per second. Of course, as soon as we started to introduce this Fastpass, we realized that we don't have tools to actually reach those speeds. So that's why one of the first features that we had to introduce when we introduced CIS Cloud Core routers, we had to introduce our own traffic generator, a program that can create traffic in enough quantity to load the device. So all the table that you see there is repeatable in a lab environment using traffic generator. We have a special manual page that you can copy, paste configuration and test it yourself. Also, until 6.33 version, we had the problem because as soon as you connect via Mac Winbox or Mac Telnet, it switches to the different driver, Ethernet driver, and switches off Fastpass. So if you upgrade to the version that's 6.33 or younger, that problem is gone. So you will be able to use Mac Winbox and Mac Telnet without worrying that your Fastpass will be disabled. And one of the first features that guys asked us when we introduced new Fastpass features was, Fastpass is very nice, but it's skipping all my other facilities, including accounting. So I cannot charge my customer for the traffic anymore. So can you please add support for traffic flow? So that's why it's also added. And most important development, I think, over last 2 years, besides the wireless rep package, is connection tracking Fastpass support. So connection tracking plus Fastpass. So now in connection tracking, you can have entries that have a fast tracked flag. So it's a special flag in connection tracking. You can mark those connections with that flag yourself by using faster connection action in a firewall. Yes?
Did you say that the contractor disables FastPath?
That's initial implementation. Now we added support for connection tracking. Now you can use connection tracking with the Fastpass. But you have to use it using fast track flags. So you yourself choose what connections you want to fast track. This works only with IP version 4 TCP and UDP traffic. So no IP version 6, no ICMP, nothing else. Just these two protocols at the moment. So, and why don't we enable it automatically? Why you have to choose what to go Fastpass and so on? As soon as you put some traffic in this Fastpass mode, the traffic will become invisible to other your facilities. So imagine networking administrator that finds out that some traffic is arriving to the interface, but you cannot see it in the firewall. That's like nightmarish situation for any system administrator that thinks about security. So that's why we gave this decision to you. So you have to make rules with fast track connection, and as soon as you make those rules, you already know yourself what traffic goes the direct way and what traffic doesn't. So it's your responsibility. So you need to track all that. But as you probably know, connection tracking have some timeouts, some states, connections, and so on. So somehow we need to replenish them, refresh them, and so on. So that's why some of the packets will go the regular way, just to make sure that ARP doesn't time out, then TCP connection doesn't time out from connection tracking, so they will pass the regular way, fix all the connections, and the Rest of the traffic will go the Fastpass way. So basically how it looks in our new connection tracking. So I hidden all source and destination addresses. It's not relevant here, but now you can see for each connection, you can see how much bytes and packets arrived and sent, and how much of that traffic went through the fast track, the fast way. So basically what we did, we teach the connection tracking to talk directly to the fast track so that it can be fast passed as in previous example. So right now you can have a configuration in a firewall and have a fast pass at the same time. Just to show you illustration how it works. So this is default firewall that we send with our default configuration from the factory. Now it comes with a faster connection by default. So here we have faster connection rule. As you can see, this rule captured only 240 megabytes of traffic, but meanwhile in the same amount of time, this amount of traffic passed through directly without going through the firewall and other facilities. So as you can see, the number difference is quite impressive. So in here, I just basically mark all the connections that have reached a related and established state in the firewall. I mark them that they can be fast-tracked. So it's quite hard, close to impossible to actually jump in the middle of the connection and do some bad things there. So most of the firewalls nowadays are built based on connection state new. So you just checked which new connections are opened and so on. So, and as if the new connection goes through your firewall successfully, you assume that rest of the packets from this connection can go without further checking through the FastPass mode. So let's talk numbers. 2011, default home access point setup from QuickSet, throughput 358 megabits, load was 100%, and if you take a look at tool profiler, you will see that firewall is taking 44% of this. So that was before FastTrack was invented. We add that one rule that I just showed you, same board, same configuration, throughput 890 megabits per second, CPU load not 100%, and firewall CPU load dropped to the 6%. So with this one simple rule, you can get almost wire speed through our software-based device. So there's no more need to buy Realtek's to get that performance. So just to summarize, so faster connection, it's an action that works very similar to mark connection. So it makes a change in connection tracking table. It doesn't do anything with the packet itself. So that's why, just to make sure that you don't drop that packet afterwards, usually when you implement faster connection, you follow it by exactly the same rule in the firewall that accepts those packets. And most common setups right now are, first of all, that I showed you, that you faster connections that have reached connection state established and related. Second most popular option is that you exclude some specific traffic that you trust for sure, that it doesn't need to go through the firewall. And the third option, you just fast track everything locals. For example, if you have DMZ, your local network and internet, everything that goes from your local network to your local servers, just fast track that. So, and take load off your CPU. So first time we introduced that, there was many tickets and support that my firewall doesn't work, my queues doesn't work, because guys enabled fast track and and lost their traffic. I see 50 megabits of traffic coming in, but I cannot capture it in the firewall. Help. So we decided to help it this way. We introduced a new feature, special dummy rule, which is actually not a rule. It's just a simple counter, which looks like a rule. And we placed it at very first position just so that you open up your firewall and you are reminded that there's some traffic that you will not capture because it goes the direct way through the FastPass. So this rule is created as soon as you have at least one faster connection in connection tracking, but it will stay there until last connection with the fast track flag will count out or be timed out from your connection tracking. So it's not like I enable the rule, dynamic rule appears, I disable faster connection rule, dynamic rule disappears. So it's based on entries, not on the state of your rule. And again, we introduced that and we got mixed replies. Some of the guys hated the idea about special dummy rule. Some of the guys loved the idea. So that's why we don't know what to do with queues. Should we introduce dummy simple queue also? Because on average per day we have at least 4 tickets stating that my queues doesn't work. So we have to, even without checking, first question, have you enabled fast track connections recently? It's like, yes. That's why the traffic is going directly. So we are still thinking about that. But what to do in the situation when your driver doesn't have FastPass support? So, for example, you use some kind of tunnel or something like that. Well, it's actually quite easy. For FastPass to operate, router needs to receive traffic on the FastPass interface. Then it will go in the FastPass mode through the so it can travel through the router without any problems, and if slow pass is needed, it can slow down. But it doesn't work other way. If you receive it on a slow pass interface, it cannot speed up and skip something. It will have to go the slow pass way all the time. So it's very, very important to have interface support on the receiving interface, or else you will not be able to use FastPass. So that's why we had a very busy winter adding support for logical interfaces. So we added bridge interface support. So now you can route through the bridge interface, and bridge interface have FastPass support. We added support for VLANs, VRPs, bondings on receive, Ethernet over IP, gray IP tunnels, and most recent development, PPPoE client and L2TP client, which of course together means that FastPass is also available for MikroTik LNS feature. So, but I need to stress it even more right now. This all works only in case you don't use encryption and you don't have fragmentation. So fragmentation and FastPass doesn't work together. So you need to be very careful if you use tunnels to make sure that you don't have fragmentation in your network. You need to have proper MTUs everywhere, change MSS segments and such things, so that there are no fragments. Because as soon as fragment arrives, it will go slow pass anyway. So basically what we did, so if previously we had a FastPass in this diagram movement, now you can have a FastPass also in this diagram movie with encapsulation and decapsulation. So basically now the whole diagram, you can have a configuration when the whole diagram is in the FastPass mode. So let's again talk about performance. So I had 2 CCRs, 36 cores connected with 10G interfaces and running a single tunnel, single PPPoE tunnel through them. So if we go way back to 6.7, when we talk about 64-byte packets, it was only 300,000 packets per second. So if we go to the first iteration of upgrade where we made the first optimization, 6.8 RC1, it was 5.5. million packets per second. And now, if you enable and configure FastPass, you can have almost full wire speed. No, it's a full wire speed basically. Over here, so close to wire speed. These are wire speeds. So 10G PPPoE connection through the CCR36 core. So same thing goes here if we have connection tracking on. As you see, numbers increase. So in this case we can use pure FastPass. In this case we can use only fast track because the connection tracking is on. So the numbers are quite impressive. So somebody can answer me why there's no 1500 here or 1518? Yes? Exactly. There's doesn't make sense to put it in here because it will be fragmented, and if it's fragmented, FastPass and fast track doesn't work. So no benefits for you there. Okay, so when we talk about these tunnels, so Ethernet over IP, GRE, IP, and layer 2 TP, we have an option for each tunnel there. It's called Allow FastPass that you need to check yourself. Again, this is for a reason, because as soon as you check this on, tunnel traffic will become invisible for all the other facilities in RouterOS. So it's up to you to decide what tunnels you want to enable FastPass and what tunnels you don't. So, and I will stress it again, fragments and encryption doesn't work with FastPass. But as I stated in the first slide, some of the traffic, sometimes some of the packets will go the regular way. So when you're building up your firewall, your queues, you need to count for that. You just can't ignore the tunnel traffic. For example, if you have in firewall, you have drop everything else strategy, and you don't account for the tunnel traffic that it might drop down to the slow pass, you will have a very strange performance. So you always need to prepare your firewall and queues so that it accounts for the possibility that tunnel goes to the slow pass, because some of the packets need to go slow pass to fix the counters and such things. So next thing, let's have the same setup as before for PPPoE. Now we go for L2TP. And as you can see, numbers here is a little bit lower, but still impressive increase if you use FastPass and Fast Track compared to the situation when you don't. So 6-7 times faster with the FastPass and 4 times faster with the Fast Track. So let's have a real life application. Home router. Provider gives you access through PPPoE client. So in this case, you don't have a PPPoE support for FastPass. You can see that it goes slow pass way. Firewall is 53% of the CPU. CPU is a 99, and you can get barely 388 megabits through this device, and everything is loaded. Now we add PPPoE client FastPass support to the equation, and you can see that firewalling is just 2%. CPU load is 95, and speed is 887, which combine it together with the PPP overhead is basically wire speed. So just by simply adding PPPoE client FastPass support, you can have this. One of the things that you also need to remember, one of the last steps in RouterOS is interface queues. When traffic gets out of the interface, it has a last place where it's queued. And the only queue type that guarantees FastPass all the way is called only hardware queue. If you put anything else here, like wireless default, it has to move to the slow pass, and then it will leave. So if you want to be pedantic about FastPass all the way through, this is last step that you need to think about to get traffic through. So, but don't worry much, it has a minimal impact on performance as it's the last step. So only one step needs to go through in the slow pass mode. Okay, let's check if you understood me. I have 4 tasks for you, and after the task I want to, each task I want you to raise your hand if you think either FastPass will work or will not work. There's no third option. So think carefully. So setup in here. So we have IP-IP1 traffic, IP-IP1 tunnel that's built on Ethernet 1. So traffic travels through the Ethernet 1 encapsulated in IP-IP tunnel and goes out through the Ethernet 2. Both of these interfaces have FastPass support. And IP-IP tunnel have allow FastPass setting enabled. So you have IP forwarding with the FastPass allowed, you have ICMP traffic, and you have a NAT, so masquerade or something like that. So who thinks that this setup will work in FastPass? Who thinks that this setup will not work in FastPass? Okay, and others? Okay, why it will not work in FastPass? Exactly. FastPass works fast track because we use NAT. Fast track works only with UDP and TCP traffic. So because of this ICMP, this setup over here will go in a slow pass mode. Okay, next task. So we have exactly the same setup, but this time packet travels other way. So it arrives through Ethernet 2 and leaves through IP-IP tunnel that's sending it out via either one. So both interfaces have FastPass support, IP-IP tunnel have allow FastPass enabled, we have IP forwarding, we have fast track TCP connection, and we have simple queues. So who thinks that this setup will work? So FastPass will work. Yes? Okay, yes. My mistake. Okay, let's assume that it's enabled. Let's assume that it's enabled. So what happens? So will it work? So support is, this is enabled, this is allowed, TCP faster connection, and simple queues. So who thinks that it will work? 1, 2, 3, 4, 5. Okay, it's getting better by the second. Okay, who thinks that it will not work? So guys who think that it will work, they are correct. But the queue will not see the traffic. So if you fast track the connection, it will skip the queues. It doesn't matter if they are there or not there, they will be skipped. Setup, FastPass works. Queues doesn't. The question was about FastPass. Okay, example number 3. A little bit more complex setup. So we have 2 ports, so wireless and Ethernet in the bridge, and the traffic arrives through the bridge port, so wired connection, and leaves through PPPoE out on Ethernet 1. Both interfaces have FastPass support. IP forwarding FastPass is allowed, and we have IP version 6 TCP connection. So who thinks that it will work? Okay, and who thinks that it will not work? Impressive. Why? Exactly. So IP version 6 doesn't have support at the moment, but it's one of the things that we are working towards to. And last example from me, so exactly the same setup, but again packet travels other way around, so it arrives from either one, from PPPoE, and goes out to the bridge port either 2. So again, both interfaces have FastPass support. We have IP forwarding FastPass allowed when we have fast track TCP connection. So who thinks that it will work? I don't need to ask other question. You are correct if you use version 6.35 or younger. If you use older version, PPPoE client support for FastPass was not added, so that's why it went slow past way. No. Bottom line, just to summarize, so FastPass is a feature that allows you to reduce CPU load in specific configurations. It's not a global solution for everything. So if you have a configuration that runs at 40% of CPU load, FastPass will not help you. Because we all know that CPU at 90%, CPU at 40%, or CPU at 10% still works instantly. CPU doesn't have to schedule anything, so it works at the same speed. Here we talk about situations when you get to 100% loads of CPU, then you can use FastPass to reduce that load and get more throughput through it. But if your CPU never gets to 100%, there's no really benefits to get FastPass for you. So yes?
Is it lower power consumption?
Yeah, I was told that Scandinavians are very green in this regard, but yes?
How about latency?
Uh,
When using FastPath or not?
If you use FastPass, you will skip all the queues and such things that can reduce your latency. But if your queues doesn't have congestion and passes without any problems, you should get the same results.
But if you have a difference in CPU utilization, it changes your latency.
It shouldn't. It shouldn't. If you don't hit 100% on single core device, on any core of the CPU can handle all the traffic instantly as the tasks come. 90%, 70%, 50%, or 10%, it doesn't matter. There is some myth going on in the networking environment that 10% of CPU load somehow is better than 19 or 90, but it's not really true. So if you don't reach 100%, you are fine. Of course, we are talking about single core solutions right now. If you have multiple cores, like 72 core device, you need to check that not even one of the CPU cores get to 100%. But basically, yes. My idea here is you can reduce your CPU load if you use FastPass. So, and what you do, you basically trade some routers functionality for performance. In case you don't use it like a typical home user that doesn't have any queues, have just basic firewall or something, it's basically no questions. They just trade for more performance and everything is fine. If you are administrating something, you need to choose. For example, can you get more throughput through this access point or through this wireless section and eliminate the possibility of using queues, for example, or such things. Those decisions are up to you. So we just give you the tools and you need to decide it yourself. Next thing, again, very, very important, is packet fragments. It's basically our worst enemy. So if you please try to avoid any packet fragmentation and fragments so that you can use FastPass properly. And the main thing is that you need FastPass support in a driver itself. So we need to write that driver. So x86 FastPass will not be really possible. There are a million drivers out there, and we are not prepared to rewrite them all, especially because we will lose the possibility to upgrade them when the manufacturers upgrade them in the Linux kernel. So on x86, FastPass support will not be coming. Okay, time for some questions.
What about the cloud-hosted router? There you write the driver.
Come again?
In the cloud-hosted router,
Uh,
there you write the virtual driver.
Most probably, yes, there will be. Currently, there's no, but we have plans for that. So, any more questions? So, okay, so then everyone is ready for raffle? Get some prizes? Or everyone waiting for beer after raffle? So, okay. Let's get the stuff going on. So mēs sākam pirmie? Kur ir mūsu dāvans? Okay, so I'm not the one that prepares the prizes, so I just given the list. So I'm just a messenger. So first that we'll be giving prizes out will be us. So I have few prizes over here, and we will start with the Hub AC. So I hope that it works the first way. Usually it doesn't. I will not try to pronounce your names correctly because it's okay. Monica I can pronounce. So first winner. Congratulations. Okay, that was fast. So next one, what I have next one here. So bonus gift pack from the mom registration. So exactly the same copy that you already had, just get an extra. Ulrich, do we have him here? Okay, very nice. Here you go, congratulations. So, one more. Soren. So, Soren here? No? 3, 2, 1, 0. If somebody knows Soren, say him my regards. Arne.
Thank you.
And as I noticed, the most exciting gift that we could give, because it's get the most attention, it's Map Lite. So the smallest devices that we have. So Timothy, are you here? No. Okay. 3, 2, 1. Still no Timothy. Next one. Alan Howard. Yes? Okay. Go.
Thanks.
Okay, that's all from MikroTik. So next one is Satellithausen and Limered, AB, yeah?
SHLAV, please.
Okay, so I think you can handle the microphone and push the button.
Yeah, I only have one gift, but it's actually combined of 3. We've had it on our table the whole day. It's an M-Ant 19S and a Net Metal Box AC. And it's also with the flexi cables